When you add and subtract rational equations, well, when you add and subtract rational expressions, but you have an equation, you still have to have common denominators. So we'll still compare the denominators and we'll still complete whatever's missing so that they'll all match. Um, like this. Here I have x for one denominator and 2, and then I have 2x. So I'll rewrite this so that there's a little bit more room to add stuff. This rational expression doesn't have a 2 in the denominator, so I need one. So I fix it like this. Just multiply by 2 over 2. And then this fraction doesn't have an x in the denominator. So that's really easy to fix. I just multiply by x over x. And this last part has the 2 and the x, so I don't have to change it. I'll distribute 2 into this first group. So when I rewrite this again, it'll look like 2x minus 5 over 2x equals x over 2x minus 1 over 2x. And now we're going to be thankful that it's an equation, so equation rules apply. You're allowed to multiply one side of the equation by something as long as you also multiply the other side of the equation by the same thing. So here, I'm going to multiply both sides of this equation by 2x, and then I won't have fractions anymore. What I've just done is I made 2x over 2x times 2x minus 5 equal to x minus 1 times 2x over 2x, which, so now I made ones. I don't need to distribute anything. I eliminated the denominators. However, before I stop writing them and stop using them, I need to make sure what the excluded values are, because those values would make the original problem not solvable. So I can't allow 2x to be equal to 0. And 2x would be equal to 0 if x was equal to 0. So my excluded value is 0. Then when I continue working on this, I don't have to keep the ones, the 2x over 2x anymore. So now what I'm solving is 2x minus 5 is equal to x minus 1. And I solve that two-step equation for x. I put the x's on one side and the numbers on the other side, and I get x is equal to 4, right? What'd I do? Oh, I see what I did. Guys, when I distributed the 2, I missed one. Here's why. I did x times 2 and I didn't do -5 times 2. This should be 2x minus 10. Sorry. So I'll subtract x from both sides and I'll add 10 to both sides. And x is 9. So I got x is 9. If I had solved and seen that x needed to be 0, I would have an extraneous solution because 0 is the value that x is not allowed to be. So in your instructions, it says to check for extraneous values. That is, be aware of what values would be excluded so that if you solve the equation and the value that you get for your solution is an excluded value, then that value would be extraneous. But my excluded value is 0 and x is equal to 9, so all is well. But always check for that. How'd that go? It's okay. Sorry for multiplying. Okay, here's the last one. This one is adding. I start by factoring the denominators and comparing these. So the denominator a squared minus a is a times a minus 1. So I have this, and then I have an a minus 1. And then I have another a times a minus 1. So 2 denominators match, and 1 is missing the a. So I multiply by a over a so that all the denominators are the same. I can rewrite this as 9a minus 18 plus 10a equals a minus 6 over a times a minus 1. Nope. Sorry. That looks so weird. Okay, there. The denominators are the same, but when you have an equal sign, it sure looks strange, doesn't it? If you put a 1 fraction line. Okay, so the denominators are still the same, but this is an equation, so. I have 9a plus 10a, that's 19a. Minus 18. So I can combine those. Also, I'm going to multiply both sides of the equation. So the whole equation gets multiplied by a times a minus 1 so that I don't have fractions anymore. And when I do that, I make sure that a is not equal to 0 or 1. Those are my excluded values. So when I rewrite this, I don't need the denominator. Of course, you can write this in more steps or whatever, but I'd like to be able to follow through your work. I get 19. Oh, that's so irritating. 19a minus 18 equals a minus 6. And when I solve for a, I get 18a equals 12. So a equals 12 over 18. Oops. Okay. 12 over 18 is not 0 and it's not 1. So this is a valid solution. That's fine. I can reduce the fraction because 12 and 18 have a common factor. 12 is 6 times 2 and 18 is 6 times 3. So here's how I reduce my fraction. I find a 1, and then a will be 2 over 3. The end. Can I answer any